right, hello everyone. Let's start with this warm-up here. Two dogs are swimming after a ball that was thrown in a pond. How far from the ball is Molly? So we want to figure out, this is our X. Oops. All right, so we know it's not a right triangle. We have 47 and 73. Let's go ahead and get that third angle by the third angle theorem. Subtract that whole thing from 180, and we get this to be 60 degrees here. So since it's not a right triangle, we can't use sine, cosine, tangent. So this was the new law that we learned, law of sines. We have a side and an angle opposite a side. So what pair do we have? We have 47 degrees, which is opposite of the, we have 73 degrees is opposite of 28. So that's our first ratio pair. So when we use the law of sines, we're going to write sine of 73 over 28. We're trying to look for that X, and what angle is opposite of the X? That is the 60 degree angle here. So I'm going to do sine 60 over X. We're going to do our cross products. So X times sine 73 to equal 28 times sine 60. We want to isolate and get X by itself, so I'm going to divide by sine 73 here. So this is what I'm going to be putting in the calculator. Pause the video and see if you get the same answer. Okay, so I get the ball from Molly is set 25 feet. All right, so today's objective is something called Law of Cosines. This is ELR. Last one we're going to learn 8.6. This is also for non-right triangles. And if you notice, we have to understand and distinguish when do we use law of sines versus law of cosines. So law of cosines is used if they give you all three sides of the triangle. And you could also use law of cosines when you have a sandwich, side, an angle in between the two sides. So here are the two formulas. Pause the video, make sure you copy this in your notebook. To find a missing side, we're doing this whole thing, a squared equals b squared plus c squared minus 2bc cosine a. And I'm going to add something on in here. To get a, the square out of the a, it's actually a equals, and then this whole thing above is going to be underneath the square root. And that's how we're going to be inputting this in our calculator. And then to find a missing angle, we're going to do cosine a equals, we have this fraction here. And again, to find an angle, the actual button in the calculator is cosine to the negative 1 of b squared plus c squared minus a squared over 2bc. And I'll talk about what b, c, and a is in these equations when we get to the next problem. All right, so here's our first problem. We are looking for side B, and here's the triangle. So you want to go through things first. Can I use sine, cosine, and tangent? Nope, because we don't know if it's a right triangle. It doesn't look like it. Can I use law of sines? Well, to use law of sines, do I have a side and an angle opposite of that side? Right now I don't. All I have is B, which is opposite of 44 degrees. That is not enough info to use law of sines. So let's talk about law of cosines. Law of cosines says side, angle, side. Do I have two sides and an angle in between? Yes, I do. I got my 10, my 22, and what's the angle in between them? 44 degrees. So I'm going to be using the formula to find a side. So let's write it down. Now, if you notice, my letters in my formula are not matching the letters on this triangle. So I don't want you to get hung up that the letters are going to match, because they're not. So since I'm looking for side B, which in my formula is A, I'm going to replace B and C, little b and little c, with 10 and 22 degrees. 22, excuse me. And what is the A here, the capital A? Well, that's the angle. That's 44 degrees. So let's go ahead and plug in those numbers. So I just plugged it in the formula, and I have my calculator to show you how I did that. So I put the whole square root, and immediately I put everything underneath the square root correctly. And I'm getting my side, which is side B in here, as 16. So this angle, this side here, is 16. You should also try it in the calculator to see if you're getting the same thing. All right, moving on to the next problem. In triangle TUV, they give you certain information here. Find the measure of angle V to the nearest tenth of a degree. So let's sketch this, label it with all the information first. Okay, I have it labeled, and I'm looking for angle V. So now let's go through everything again. I don't know if it's a right triangle, so I'm not going to use sine, cosine, and tangent. Could I use law of sines? I have no idea of any of the angles opposite any of those three sides. So this has to be law of cosines because I am giving three sides. Remember, there were two cases, SSS and SAS, when you could use law of cosines. So I'm going to be using that one. So let's write down the equation for SSS for finding an angle. Okay, so since I am looking for angle V, if you take a look in the formula, it's labeled as A. So that's going to be cosine V. Now, also, where is there A in the formula? Right over here at the end. And that's little a, so that's the side. So most important in this formula for finding an angle is that you actually put the side of the angle that you're looking for as that minus a squared. So what is the side that's opposite of the angle I'm looking for? That's 4.4. This is going to be replaced at the very end, minus 4.4 squared. What are the other two, B and C? That's going to be the 6.7 and the 7.1. All right, so I have everything there correctly. Again, stressing that the angle you're looking for with that side, that's the only spot you're going to see it, which is the 4.4 at the end. Now to input this in the calculator, we know to find an angle, that's the cosine to the -1. So that's what I need to do. Put this all in parentheses here. And most important, if you take a look at the calculator piece that I have shown there, is that you have parentheses, around your numerator and your denominator. Okay, so I have it shown there on the left with the calculator. And then what do they get for the angle V to the nearest tenth of a degree? That would be 37.0 degrees is the answer for angle V. Okay, next problem. We want to find the value of x and y and round to the nearest tenth for each. So again, I go through the whole process. Can I use sine, cosine, and tangent? No, I cannot. Can I use law of sines? I don't think so because I don't have an angle with a side that I know opposite of it. There we have x, which is opposite of 40, and then I don't even know the angle opposite of 78 or the one opposite of 80. Is this law of cosines? Which one is it? It's the SAS, sandwich one, two sides with the angle in between. So let's write down that formula to find the side, which is the x here. All right, so when you plug in your numbers here, you're having 80 and 78 as the B and the C. Angle A there has to be the one that's opposite of the side you're looking for, which is going to be the 40 degrees. Okay, so I have the calculator shown on the bottom here. We get 54.1 because I said to the nearest tenth. So I'm going to put that in the picture here. All right, now we need to find angle Y. So let's take a look here. Can't use sine, cosine, or tangent. Can I use law of sines now? I think I can because now I have an angle, right, and a side opposite the angle. And then I can figure out Y because I have 80 opposite of Y. So I'm going to now use law of sines to find Y. Okay, here's my setup of my law of sines. Sine 40 over 54.1 to equal sine Y over 80. I'm going to do my cross multiplication. Okay, so I'm up to this point where I get sine Y equals 80 times sine 40 over 54.1. Again, you have to remember that this means to find an angle. So in my calculator, I'm actually doing sine to the -1. And then in parentheses, I have 80 times sine 40, all divided by the 54.1. Okay, in the calculator, I get it to be 71.9 degrees for angle Y. All right, moving on now. So we're going to take a look at different triangles, how they're labeled. And even though you're not in class today, see if you can figure out would I use law of sines in this problem or law of cosines. So here we go. First one. Which law would you use for this one? This one is law of cosines because I have SAS, the sandwich there, 5 and 7, not 70 degrees is in between, so I can find that B side. Next one. This also would be law of cosines because I have side, side, side. That's that second case for law of cosines, 3 sides. Okay, what about this one here? This one, you could definitely use law of sines. I have this side opposite of 85 degrees. I could find this side here if they asked me for it, or the other one. So this is law of sines. All right, how about this one here? This one again, let's take a look. We could use law of sines. We could figure out this third angle by the third angle theorem. And we know this side is opposite. And then I could get any of the other 2 sides because I have the 28 degrees or the 76. All right, this one here, this would be law of cosines because it's the sandwich again, SAS, 2 sides with the angle in between, 4 and 6, 115 is between. All right, last one. What law is this one? This is also law of cosines. SSS. All right, so that's it for the ELR 8.6. I want to go over about our portfolio for today. That's for this unit. It's called a clinometer portfolio. And what's a clinometer? It's an instrument that measures angles of slope, elevation, or depression of an object. So it measures the incline as an observer is looking upwards and decline as is looking downwards. So this is the example of what I have that you're going to be using outside with measuring tape. So your objective, if you opened up the portfolio already, is to measure 2 objects outside using this clinometer, having your friend help you. So let's pretend our object is the flagpole in front of the school. You need to stand some distance away from the flagpole, looking through the straw with your eyes here. You're looking up to see the top of the flagpole through the straw. So you want to have yourself somewhere away from the flagpole so that you could see the top of it. All right, so when you have done that and you are standing there, your friend has to tell you what the angle is here, the angle that you're looking up as when you're looking through this clinometer. And that angle, this angle here that you're getting, is what angle A is up here. So this angle that you're getting here is the same as this angle over here. So let's say it's, I don't know, 30 degrees. Write 30 degrees in your notebook. You and your friend also need to make a mark with chalk and measure using the measuring tape what that distance is you are from the flagpole. So that would be the distance for ZY. I don't know, let's say it's 40 feet. YG is, now you could do this inside the classroom or outside, is measuring your height from your eyeballs down to the ground. Let's say that is, I don't know, 5 feet 3 inches. Now that you have all the info that you need, you could find the height of the flagpole. Take a look at the portfolio. There's another section there that you also have to do. That's a word problem. And if you have any more questions on that, you could ask me.